Kerala, the land renowned for its lush greenery, backwaters, picturesque beaches, tranquil hill stations, and vibrant cultural heritage. The state has unique geographical features such as Western Ghats run parallel to the eastern part of the state, coastal plains that stretches along the Arabian Sea. Its terrain, which is crisscrossed by numerous rivers, play a key factor in shaping its environment, culture, and economy. This diversified physiography of the state plays a crucial role in determining its weather and climate. Meteorological Centre Thiruvananthapuram caters to the meteorological requirements of Kerala state and Lakshadweep Islands by providing weather services in the state.
India Meteorological Department is the nodal agency for providing weather forecast, both aviation and non-aviation, for optimum weather sensitive activities like agricultural, aviation, irrigation, etc., and warnings against severe weather phenomena over the state and nearby sea areas like heavy rains, thunderstorms, strong winds, etc. Meteorological Observatory Thiruvananthapuram took to its origin in 1836 from the erstwhile Trivandrum Observatory established by Maharaja Swathi Tirunal of Travancore in 1836. Observatory of this office has been taking weather observations for more than 180 years.
As weather a global phenomena, it has to be observed and recorded all over the globe synchronously for its prediction. MC Thiruvananthapuram is mandated to maintain a network of observatories over the state and Lakshadweep Islands. The network comprises of 16 surface observatories, 4 upper air observatories, 69 rain gauge stations, 140 automated weather stations, and automated rain gauges. Weather is recorded in terms of a number of parameters called meteorological elements.
Precipitation is expressed as the depth which would cover the horizontal projection of the Earth's surface. Here we are using the precipitation, that is rainfall, using the non-recording rain gauge. We can also measure the rainfall amount with the help of the self-recording rain gauge. Temperature is the degree of hotness and coldness. Here we are using 4 atmospheric temperatures: dry bulb, maximum temperature, minimum temperature, and wet bulb temperature. Dry bulb temperature we are using for measuring the temperature of the air above the ground. Maximum temperature will give the maximum temperature attained by the air after the last resetting. Minimum temperature will give you the minimum temperature attained by the air since the last setting. Wet bulb in conjunction with the dry bulb give us the dew point and the relative humidity.
The pressure of the atmosphere is the weight of air column which stands vertically above the unit area. Atmospheric pressure is measured as millibar or hectopascal. This is cube pattern barometer which is used to measure atmospheric pressure.
Wind is actually defined as the motion of air, and it is expressed in terms of wind speed and wind direction. As you all know that wind is a vector quantity, so we have to measure the speed at which the wind is blowing at a place. At the same time, we have to detect the direction from which the wind is blowing. So here you can see this is a wind vane, and it is an instrument which is used for detecting the direction from which the wind is blowing. The wind speed at a place is measured using an instrument called cup-counted anemometer. As the name suggests, this instrument is provided with 3 different conical cups that are arranged at an angle of 120 degrees. And due to the force at which the wind is blowing over this instrument, these cups begins to rotate. And the distance rotated by these cups will be used for finding the wind speed at that place. Cloud coverage at a place is very important while determining the weather at a place. And cloud coverage is actually an estimated quantity. It's a non-instrumental quantity, and the sky is divided into 8 parts, and we will be measuring how much parts of the sky is covered when all these clouds are put together, and it is used for the measurement of, or it is used for estimation of the cloud at that particular place, and this number is getting reported into meteorological messages, and that is used for the weather forecasting purpose. Another important meteorological element that defines the weather at a place is visibility. Visibility, we are measuring the horizontal visibility, means the maximum horizontal distance at which an observer can easily see an object distinctly. That is defined as the visibility at an observatory.
These meteorological elements are observed about 8 times in a day all over the observatories at the same time. Observing these meteorological elements only on surface could not meet the requirements for weather prediction. Hence, these met elements have to be observed at higher levels of the atmosphere. As observing atmospheric conditions of upper atmosphere indicative of forthcoming surface weather phenomena, it is accomplished by sending instruments provided with sensors and capable of telemetry using hydrogen-filled balloons.
The weather and atmospheric systems are not dictated by surface parameters alone. The upper air conditions are also very important for understanding the changes of temperature, pressure, relative humidity and rainfall. So we have 2 systems at the office. The first one is the radio sonde system, which you have at my left hand side, and you have a pilot sonde system on the right hand side. So these are the 2 instruments that we use for upper air observations. The thing with the radio sonde system is that we have 2 sensors on board, a temperature and a relative humidity sensor, but for a pilot sonde system there is no sensors, but both of them have GPS tracking enabled to them. So what we do is that we just configure both of them and then connect it to a hydrogen balloon and send it into the atmosphere. So then what happens is that we will get the data from this through the receiver which is there at the ground station. And the difference between the 2 is that the radio sonde instrument gives us measurements of temperature, pressure, wind direction, wind speed and relative humidity, but the pilot sonde instrument only gives you measurements of wind direction and wind speed. So that makes the radio sonde instrument a much more comprehensive system as far as understanding the upper air atmosphere is concerned. For both of them, the data which is received from the instruments will be coded as a coded message as per the WMO norms. And after that they will be transmitted to analyzing centers for developing forecasts. Now these systems, both of them will give us pictorial representations also, like STUV diagram, trajectory of the balloon, T5 grams, T-log-P plots and stuff like that.
The observational data from surface and upper air observatories are collected and transmitted to headquarters at New Delhi through web-based meteorological data transmission and retrieval mode of communication. HQ retransmits the data pertaining to India and neighboring countries to individual observatories. Based on these data, plotting of surface and upper air charts are done. The observational data finally collected at headquarters from all observatories and various other data from satellites, radars, marine observatories, automated weather stations are ingested into numerical weather prediction model, which is a high computing system capable of predicting the evolution of atmospheric parameters in advance of time using the observed data as initial conditions.
Based on numerical weather prediction model guidance and other forecasting methodologies, daily we are preparing subdivision precipitation forecast, intensity forecast, temperature forecast, and other disaster weather warning if any disaster event is expected. These are prepared and proposed in a daily video conferencing with our National Forecasting Division at Delhi, and it is finalized there. After that, we are issuing subdivision forecast for next 7 days and intensity forecast for next 5 days, and nowcast whenever necessary, and port warning, coastal warning, and wind warning for fishermen on daily basis. Daily district-wise quantitative weather forecast for 7 weather parameters for farmers. Daily block level weather forecast for 7 weather parameters for farmers. Quantitative precipitation forecast and hydromet bulletin for flood monitoring, and nowcasts are issued, and district level rainfall forecast is issued in color codes.
The Cyclone Warning Centre in Thiruvananthapuram functions under the Area Cyclone Warning Centre in Chennai under the guidance of Regional Specialized Meteorological Centre, New Delhi. Cyclone Warning Centre Thiruvananthapuram monitors the weather and issues special bulletins to disaster managers during cyclonic storms and depressions formed over Arabian Sea with a specific reference to Kerala Karnataka coasts and Lakshadweep area. Let us look into the advisories issued by CWC Thiruvananthapuram.
Cyclone Warning Centre Thiruvananthapuram is responsible for issuing fishermen warning to Kerala, Karnataka coast and over Lakshadweep area. Whenever wind speed over sea area exceed 45 km per hour, fishermen warnings are issued, and the same is sent to Director of Fisheries and other concerned authorities, advising fishermen not to venture into the open sea. Normally, fishermen warnings are issued 4 times in a day. Fisherman bulletin contains wind warning, a rough sea alert for coast and open sea. Also, graphics are included for better understanding.
Cyclone Warning Centre Thiruvananthapuram issues coastal bulletins for coastal shipping in Kerala, Karnataka area and Lakshadweep. These are based on sea area bulletins. Normally, we are issuing 2 bulletins daily based on 3 UTC and 12 UTC observations. During depression or deep depression, we are issuing an additional bulletin based on 18 UTC observations. During cyclone, 6 numbers coastal bulletins are issued, and it contains information on significant synoptic features, then expected weather, wind, visibility, sea condition and port warnings also.
Area Cyclone Warning Centre and Cyclone Warning Centre are responsible for the forecast of cyclone formation in the Bay of Bengal and Arabian Sea. This is issued by the concerned CWC centers. This bulletin is issued to the chief secretaries and other maritime district collectors and to other higher officials in advance of 48 hours.
In addition to these forecasts, MC Thiruvananthapuram also issues short-range forecasts for next 3 hours called nowcasts.
Nowcasting describes the detailed description of current weather along with forecasts obtained by the extrapolation of extrapolation for a period of 0 to 3 hours. In this frame, it is possible to forecast small-scale features such as individual storms with reasonable accuracy. A forecaster uses latest satellite, radar, and observational data which are used to make analysis of the small-scale features present in small areas such as city and make an accurate forecast for the following few hours. It is therefore a powerful tool for warning the public.
In order to improve public outreach and understandability, MC Thiruvananthapuram issues impact-based forecasts, which projects what the weather will do rather than what the weather will be.
Impact-based forecasts are issued in advance during severe weather events such as cyclones, heavy rainfall, cold wave, heat wave, etc. Expected impact on public life during such weather events and the guidelines for the necessary actions during such severe weather are provided in the weather warnings.
In addition to a highly functional manual observatory network, MC Thiruvananthapuram also has a dense network of automated weather stations.
This is an automatic weather station, AWS. An automatic weather station is a station in which meteorological parameters are observed and recorded and transmitted automatically. Since 1980s, IMD established so many automatic weather stations. At that time, it was known as Data Collection Platform, DCPs. Since 1990s, automatic weather stations were established, and now after 2018 floods, Government of Kerala proposed 100 more AWS by IMD in Kerala, and now we have already established most of the AWS, and we are having a network of 140 automatic weather station and 29 automatic rain gauge ARGs. The main components of automatic weather stations are its sensors and a data logger and a battery and battery charges, its transmitter and Yagi antenna. The sensors are for temperature, humidity, wind speed, wind direction, rainfall, leaf temperature, leaf wetness, radiation parameters, and soil moisture, etc. Soil moisture and soil temperature, etc.
On this occasion, commemorating the 150th anniversary of India Meteorological Department, which continues its pivotal role in safeguarding lives and livelihoods across the country.